Bismillahirrahmanirrahim and Assalamu alaikum. As in the previous lecture, I have told you about the types of chemical bond, that there are four types of chemical bonds: the ionic bond, covalent bond, coordinate covalent bond, and metallic bond. Today we will discuss the first type of chemical bond, which is an ionic bond. This is the type of chemical bond formed due to the complete transfer of electron or electrons from one atom to another atom. It is also said to be the electrovalent bond. The atom which loses electron will form a cation, while the atom which gain electron form an anion. So opposite charge ions are formed. These opposite charge ions attract each other due to electrostatic force of attraction, and such type of bond is said to be the ionic bond. As the name indicates, ions are formed during the formation of such bond. Therefore, ionic bond can also be defined as the type of chemical bond which is formed by the electrostatic force of attraction between oppositely charged ion is called an ionic bond. The formation of ionic bond leads to the completion of octet or duplet. When atom transfer their electron, then both atom will have to complete its octet or duplet. It may complete 8 electron in its valence shell or completing 2 electron in its valence shell. In both cases, and both atoms get noble gas valence shell electronic configuration. So after the formation of ionic bond, both atom will get noble gas valence shell electronic configuration, and hence they will get stabilized. There are some conditions for formation of ionic bond. Ionic bond is formed between metals and non-metal, or it may form between more electropositive element and more electronegative element. Element in the first A and second A, which are metal, will combine with the element of 6 and 7A, which are non-metal. So they combine together, and the transfer of electron take place from metal to non-metal, leading the formation of ionic bond. One atom loses electrons. It will have low ionization energy. Such atom is atom of metal, and after losing electron, it will form a cation. The other atom gain electron, it will have high electron affinity. It will be a non-metal, and after gaining electron, it will form an anion, a negative charged ion. The electronegativity difference between two atoms is greater than 1.7. When we calculate the electronegativity difference between two bonded atoms, the difference will be more than 1.7. During the reaction, opposite charge ions are formed. It means that cation and anion are formed, and the cation and anion will have to attract one another due to electrostatic force of attraction. For example, let's suppose we have atom A, which is a metal atom, and it has low ionization energy. When it loses electron, it will form a cation. The other element, the other atom is the atom of non-metal. When it gains an electron, it will form an anion. So opposite charge ions are formed. A is cation, while B minus is an anion. Therefore, the electrostatic force of attraction, the opposite charge ions attract each other, and this attractive force leads to the formation of ionic bond. Now let's take a simple example of formation of ionic bond. Sodium chloride is formed when sodium reacts with fluorine. The type of chemical bond between sodium chloride is ionic bond. We know that the atomic number of sodium is 11. The electronic configuration of sodium: in the first shell it has 2 electrons, in the second it containing 8 electrons, while in the last shell it contains only 1 electron. So it is easy for sodium to lose 1 electron rather to gain 7 electrons to complete its octet. Therefore, sodium has to lose its only electron in valence shell, and it will form sodium ion. After losing electron, the valence shell now containing 8 electrons. So it means that after losing electrons, sodium get noble gas valence shell electronic configuration. Similarly, the atomic number of chlorine is 17. The electronic configuration, it has 2 electrons in the first shell, 8 electrons in the second shell, and 7 electrons in the last shell. It means that if chlorine gain an electron, then it complete 8 electron in outermost shell. So after gaining 1 electron, a chloride ion is formed, and with the formation of chloride ion, the valence shell now containing 8 electron, it completes its octet. Now during the transfer of electron, both atoms get noble gas valence shell electronic configuration. The opposite charge ions are formed. Sodium, being positive charge ion, attract the chloride ion, forming sodium chloride. So such type of bond is said to be the ionic bond. Now let's explain the formation of ionic bond between sodium and chloride diagrammatically. If we look at the valence shell of sodium, it containing only 1 electron, while the valence shell of chlorine containing 7 electrons. So to complete its octet, sodium would have to lose its 1 electron. When this electron is transferred to chlorine atom, the inner shell, which is now the valence shell, will containing 8 electrons. So the outermost shell acquire or get 8 electron and complete its octet. When chlorine atom, which has 7 electron in its valence shell, gain an electron from sodium, it also get 8 electron in its outermost shell and hence complete its octet. Now after the transfer of electrons, sodium and chloride ion are formed. These sodium and chloride ion attract each other, which leads to the formation of ionic bond. This is the simple lattice, the crystalline structure of sodium chloride, in which each sodium is bonded with chloride, and this attraction and this formation and this arrangement is alternate fashion. It means that positive ion followed by a negative, then positive, negative, and so on. So a cubic lattice is formed, but the explanation of this lattice is beyond the scope of this book. We will discuss it in the next classes. In calcium chloride, there is also an ionic bond between calcium and chlorine. If you look at the formula, each calcium is bonded with 2 chloride ions. Now starting from the atomic number of calcium, which is 20. Electronic configuration of calcium is, in the first shell there are 2 electrons, in the second shell there are 8 electrons, in the next third shell there are 8 electrons, while in the final, in the valence shell there are 2 electrons. It means that if calcium wants to get stability, it will have either to gain 6 electrons or to lose 2 electrons. Gaining or 6 electrons is rather difficult, so calcium has the tendency to lose 2 electrons in the valence shell and form divalent cation. If you look at, there is a double positive charge, divalent cation. After losing electron, it gets valence shell, noble gas valence shell electronic configuration, and it completes its octet by acquiring 8 electrons in its valence shell. Similarly, atomic number of chlorine is 17. It has 7 electrons in its outermost shell. Therefore, chlorine gains 1 electron and will form chloride ion. Now, for gaining 2 electrons from calcium, we need 2 chloride ion, because 1 chlorine can only gain 1 electron. So when calcium loses 2 electrons, 2 chlorine atom will gain 1 electron each and will form 2 chloride ions. Now the diagrammatic representation, the structural representation of formation of ionic bond. Look at the valence shell of calcium, it containing 2 electrons in its valence shell. Chloride containing 7 electrons in its valence shell. Chlorine containing 7 electrons in its valence shell. So calcium give 1 electron to 1 chlorine and give another electron to another chlorine. So the divalent cation of calcium will combine with 2 chloride ion and form calcium chloride. Remember again that after losing the valence electron, both chlorine and calcium acquire noble gas valence shell electronic configuration. So it is all about the ionic bond, definition of ionic bond, the conditions of ionic bond, the examples of ionic bond, example of calcium chloride, sodium chloride. I hope that you have understood the topic. Inshallah, we will discuss covalent bond in the next lecture. So goodbye and have a nice day.